Now let's take question number 51. Here this question is based on surface areas and volumes, and the question states there is a right circular cone of height h and vertical angle 60 degree. A sphere, when placed inside the cone, it touches the curved surface and the base of the cone. That means we can say the sphere is inscribed in the given cone. Further, we have to calculate the volume of the inscribed sphere. So for finding the volume of the sphere, we first calculate the radius of the given sphere. Now first let's draw the diagram that represent the given information. Here we can see that we have a sphere of radius small r is inscribed in a cone of base radius capital R, and the height of this cone is h unit. So here we can see that this ADC is a right angle. That means we can apply the concept of trigonometry in triangle ADC. So here we can write tan 30 degree, which is equal to 1 upon root 3, is equal to perpendicular divided by base. That means capital R divided by h. So here we can calculate the value of r is equal to h upon root 3 units. So this is the base radius of cone in terms of height of the given cone. Further, here we can see that ADC is a right triangle. We can also apply the concept of Pythagoras theorem, and as per the Pythagoras theorem, here we can write AC square, that means hypotenuse, is equal to sum of the squares of the remaining two sides. That means AD square plus DC square. So here the length of AD, the height of the cone, and DC, the base radius of the cone, that means capital R square. So when we put the value of r is equal to h upon root 3, so what we'll get here? We'll get here the value of h square plus h square upon 3. That means 4h square upon 3. That means the length of line segment AC is equal to 2h upon root 3 units. Here we have the length of line segment AC, and we know that the length of CD is equal to length of CE, because here BC and AC are tangents to the given sphere. That means we know the concept, the tangents drawn from external point are equal in length. So that's why we are taking the length of CE is equal to r unit. So here we can calculate the length of AE because we have the length of AC. So what is the length of AE here? So here we can write the length of AE is equal to the length of AC minus the length of CE. So what we get here? AC, which is equal to 2h upon root 3 unit, minus CE, as we determine it is equal to r, and r is equal to h upon root 3. So here we will replace CE by h upon root 3. So ultimately here we are getting the length of line segment AE is equal to h upon root 3 unit. Now we can further apply the concept of trigonometry in right triangle AOE. So what we'll get here? So when we apply tan 30 degree in right triangle AEO, so tan 30 degree, which is again equal to 1 upon root 3, is equal to perpendicular divided by base. That means small r divided by the length of line segment AE. AE is equal to h upon root 3 units. So here we can write the value of r is equal to h upon root 3 unit divided by root 3. So here we will get the length of r, which is equal to h upon 3. Here we get the radius of the inscribed sphere. Now students, here we have to calculate the volume of the given sphere. So what is the volume of a sphere? 4 by 3 pi r cube. So when we put the value of r in formula 4 by 3 pi r cube, we'll get the fourth option is the correct answer. That means the volume will be equal to 4 by 3 pi r cube, and r is equal to h by 3. When we place the value of r is here, then we'll get the volume as 4 upon 81 pi h cube. So option 4 is correct here. Now the answer for this question is option number 4. Now, let us move forward to question number 52.